Hello students, welcome back to the next module of the chapter called electrostatics. Now students, in the previous module we have learned few important points which we'll be needing for the derivation of mechanical force per unit area, right? Now let us focus on the another situation or rather another concept that we'll be needing for the derivation of mechanical force per unit area, right? So let us start. Now see the situation carefully. Right? Now in this particular situation, we are provided with the positively charged body, right? And the charge on this particular body is divided into two parts. First one is elemental charge dq, which is present on small area ds, and rest is remaining charge on the body, right? And here we are supposed to find out the magnitude of intensities at point A, which is just outside, and at point B, which is just inside. At the same time, we are also supposed to find out the direction of intensities E1 and E2, which are produced by the elemental charge and the remaining charge on the body, right, at point A and at point B, right? So let us start with the solution. Right, first of all we'll consider point A. Now see point A carefully. Now this point A is situated just outside the charge body, right? Do you remember third application of Gauss theorem? Yes. Now as point A is situated just outside the charge body, intensity at point A, or rather magnitude of intensity at point A, is given by the formula EA, it is equal to sigma upon epsilon, where sigma is surface charge density, epsilon is the permittivity of the medium, which can further be written as epsilon naught K, right? So let us move further. So this EA, it is equal to sigma upon epsilon, is the magnitude of intensity at point A, right? Now let us move towards the next part, that is direction, right? Now first of all we'll be finding direction due to elemental charge ds, right? Now see elemental charge ds. Now it is on the left hand side of point A. Point A is on the right. So in this case, the intensity E1 due to elemental charge dq on element ds will be directed rightward. So in this case, it will be directed like this. So this is direction of E1, which is produced by the elemental charge on element ds. Right? Now let us consider the direction of intensity which is produced by the remaining charge of the body. Now students, see carefully the above diagram, right? Now all the charges are present on left and point A is on right. Now for positive charge, intensity is always directed away from the charge. So if I consider this section of charge, all the charge is concentrated towards left. So because of this, intensity will be directed towards right. So in this case, intensity E2, which is produced because of the remaining charge on the body, it is again directed towards right. So this is nothing but direction of intensity E2, right? So in this particular situation, for point A, which is just outside the charge body, both the intensities are in the same direction, where E1 is the intensity due to elemental charge dq on elemental area ds, and E2 is the intensity which is produced by the remaining charge on the body, right? Now let us move further. Let us calculate the same parameters for point B, which is just inside, right? Now see point B, it is just inside. Now is there any charge inside the body? No, there is no charge inside the body. And as there is no charge inside the body, net magnitude or rather magnitude of intensity at point B will always be equal to 0. So I can say intensity at point B, it is equal to 0, and this is nothing but the magnitude of intensity at point B, right? Now let us see the direction part. Now see elemental area ds, right? It is on the right hand side of point B. So because of this charge, intensity will be produced in this particular direction. Why? Because point B is on the left hand side. So that's why intensity E1 will have this particular direction, right? Now students, again, now point B is inside the charge body, right? Now as it is inside the charge body, intensity at point B should be 0, right? Now in order that intensity becomes 0, the intensity of remaining charge should oppose E1, right? So therefore intensity at point B due to remaining charges will be in the opposite direction as that of E1, right? So this is nothing but direction of intensity E2 due to remaining charges on the body, right? So for point A, both the intensities are in the same direction, and for point B, which is just inside, both the intensities are in opposite direction, so that net intensity at point B becomes 0. right? So students, in this particular module, we have analyzed the given situation and we came to conclusion that for any point outside the charge body of any shape, both the intensities E1 and E2 due to elemental charge and the remaining charge is in the same direction, but for point B, which is inside, both the intensities are in the opposite direction, right? So students, this situation is very important. We'll be using this situation in the forthcoming module. So that's it for this particular module. I'll see you in the next module. Till then, keep learning.